Okay, so we've got that code there as an idea of this is the stuff that we want to steal, an array and a next free slot piece of information. And I've made a union worker class that just has a first name and some sort of job title. And again, this is really just becomes cannon fodder for filling the lists. And we're going to do that a lot. We're going to make some trivial class just as a thing to store into the lists, and then we're going to move things in and out of them. So, given that we've got this worker class, let's write something that will manage a membership class. So we'll call that member list. And what I'm going to do is I'm going to go back to our driver idea, and I'm going to say, well, it looks like what we're using is an array of things, which in this case, instead of students, is union members. And so I'm going to plug that in as one of the things that we need to keep track of, which is a worker. And it's not just one worker variable, but a bunch of worker variables. And along with that, we said that we also had to have, oops, what did I do here? Worker array, all workers, that's a little better, in the right spot. And then we'll do private int last free slot, last free position, anything that gives that variable an idea that it's both something that's a number that refers to an array position, that it's the free one we're interested in rather than the full one. We'll initialize both those variables. With the constructor. And so we're going to say all workers equals new worker array. And there's the first problem with arrays. How big do you want to make it? What would be a good number? Yeah, you know, I mean, the problem here is the instant you pick any number out of the hat, you automatically have a problem of, well, if my union grows beyond that size because we go cross Canada or whatever we happen to do, then that number could get very large. Okay? But for now, we're just not going to worry about it, and we'll see if we can come up with a better solution later. So what we'll do for a size in here is we'll just put some arbitrarily small number that we can work with, and we'll go fix it later. So that'll work for the first 10 of them, good enough. And the last free slot then becomes exactly the 0, 1. Okay. Last free slot or first free slot?
This last one, because it's the last one in the list.
How about
Next free slot.
next free to fill? Not much doubt about what that means, so we'll leave it like that for a while. Okay. How are people going to get stuff into this class? Need an add method. So now we have to write methods that are going to take stuff in and dump it into the array. So we'll need an add. The thing that you're going to add is a worker. I'm too lazy to figure out what that's going to do for a moment. After you've got them in, how are you going to get them out? By what? You got to have some way of saying go retrieve one. So that's going to be public, give me a worker back, get one. What are you going to give it as information to retrieve something?
Its position.
Its position, sure. too lazy to think about that one for a moment. Okay.
Move.
Before we even think about removing something, suppose that I wanted to go look at all of the people who were in my union so far. What would the main program do? Would get the 0, 1, it would get the number 1, it would get the number 2.
Print them all until it ran
When would it know when to stop?
when you reach C, yeah.
When you reach the end. Now, there's two different ends here. There's the end of the array, but that's not necessarily the number of people who are actually in the union, because we have more space than we have union members.
You need to find out how many are in the array so far.
So the only way that somebody's going to be able to write a loop to show you all of the people is if they go through and they know how many are in there. So we need public int size that returns something. For now, I'm just going to make it return something totally arbitrary, but that gets the syntax errors out of it. Okay? So one really common thing is that anytime you start working with positional notation, you end up having two pieces of information that are required. You not only have to have something that says, get me this one, but you have to know what the last position is all the time for when you run your loop. That's the joys of counting.
Isn't size a little ambiguous because it doesn't specify whether it's
Yeah.
total size or
Yeah,
build
we'll
size?
talk about, there's a difference between size, the number of people that are in there, and capacity, the amount of things that you can hold. Okay, yeah, and so size is sort of one of those funny words. Okay, but for now, that's enough. Okay, that's enough to at least get started, and we can store union members in, and maybe nobody ever gets fired or quits, and life is really good. What's the thing that we should do next? One of those trick questions again.
Add 1 to the next free, like certain function, you can add 1 to the next.
No. Think back to 132. We've got something that is obviously broken, but
Oh, you need
Or
to be
you
able
could-
to change the size of the array, the total
You're
size.
going to give it the list.
forget about the
All people's.
details, just overall big picture. What would be the best thing to do at this point before you go any farther with member list?
Test it.
Write the unit tests. Because we already have something here with syntax errors out of it that we know that's broken. But before we go about writing code to try to meet some unknown expectations, why don't we write out exactly what the expectations are? And that will save you from always having to go back and say, well, okay, just let me see if I can get this to work. Oh, just let me see. Oh, let me use the debugger. Let me play all of these games. Either it works or it doesn't. Okay? So the very next thing I'm going to do is I'm going to just stop for a second and say, well, this would be a good time to write some unit tests. So let's write member list test. Let's include a setup method. And let's make some stuff here. So we need worker A. I'm just going to make a bunch of cannon fodder workers. So there's a bunch of workers. A equals takes 2 arguments. And notice, just to emphasize my point here about these things being cannon fodder, we no longer really care about what's inside the things, because all that we're really interested in is that they have different memory addresses, because that's eventually what we're going to be testing against. So the contents of these things are totally immaterial, but just in case we happen to be looking at them in the debugger, so that we don't confuse ourselves, I'm going to change these things to look like something a little bit more reasonable. Okay, so here's our first test. So if we were to go make a new member list, I guess I'll call it, just because it's really specific, I'll call it union. We'll make a new member list. If we make a new list, what should be true?
Should have no nothing.
It should be empty. Wouldn't want to have it magically filled. Anything else we should test?
Then the next free slot is 0?
You could try to test to see whether or not there's nobody in the 0 position. The question is that a good idea? Okay. One of the rules that we had last term was to say we're only going to test things that are valid or expected for normal conditions. So it would be an abnormal condition to say size is 0, but there's somebody there. So if size was 1, yes, I would think about seeing whether or not there was actually somebody in slot 0. But here, about the only thing that you can test is to say if it says it's empty, it's empty. That's the best you can do. So we're not going to be concerned with testing beyond the bounds of something that's reasonable for now. That's a whole different idea. Okay?
I think he meant like check that the frame variable is the next free slot is equal to 0.
Well, that's what size is giving you is next free slot, so that's,
Oh, is it?
yeah, that's all you can, that's basically, this is the only, really the only check you can do. So yet another little trick question, don't test things that are outside the bounds for now. Let's just worry about testing the conditions that should work normally. Okay, how about another test? What do you want to test next?
He's gonna add somebody.
But you can add somebody, so we'll do just add one person. And if we added one person, we would do, I guess the sneaky thing here would be to make a union variable here. Wow. We called it union, didn't we? Just to save ourselves some time here, a new member list. So we'll do that there. Get rid of that thing down there, just to make that case easier. And now you want to add one, so that's going to be union dot add a. And now what can you say is true?
Union size is 1.
So the size should now be 1. And
that the individual at position 0 is A.
and that the person at position, which position?
0.
0 had better be exactly A. Okay, so they're identical to A, not somebody who looks like A, same guy I put in. Okay. And while we're at it, let's just now copy that test and do add 2 just for the pure fun of it. And if we already know that that works, so we'll just do union add A and B. And now the size should be 2, and the 0 should be that, and the number 1 position should be B. Okay, so we could go on and we could write some more, but that's probably good enough for a start. And so now you can run the unit tests, and not surprisingly, they don't really work very well. Okay, so now that we've got some unit tests that at least go and see whether or not stuff works, we'll go back to member list. What should add do?
Should do all workers that I have.
All workers. Remember, this is an array, so there's no add method. So
Workers, yeah, and then it should take the next free to fill position.
So next free to fill
Equals who?
should get whoever we're looking for.
Then increment next free to fill.
Just out of interest's sake, suppose that that was all that you felt like doing, because you thought that should sort of solve the problem. Let's just do a get here. Get needs to return all workers sub whatever position they give, and size returns what?
Next free to fill.
Next free to fill, or next free to fill minus 1 or plus 1, or
Just that.
just that. Okay, that's correct, because if you don't put anything in and you say how many items are in it, you get back the 0. Okay, so it's actually correct that way and not some different way. The reason I point that out is because that next free to fill variable is actually serving 2 different purposes, 2 different thought processes. It's both telling you what the next position is to fill, but that also happens to be the size, the number of items that are on the list. And that's sort of one thing to keep clear in your mind, because sometimes when we're writing a little bit of code later on, if you need number of items on a list or inside this thing, it's actually that variable. Okay, or you can just use size, but it's easier to use next to fill. Okay, so that's as far as I felt like going with that thing. Run the unit tests and see what happens, and it still fails on add 1, and the reason it fails is it says, oh, the size is wrong. Okay, so there's the joy of the unit test. Size comes from the next slot to fill variable. And so now I know that something probably in add didn't do what it was supposed to do with that variable. Okay, so even if you write bad code, you can use the debugger and the combination of the unit tests and the debugger to really quickly help you find out what the problem is. So in this case, next free to fill needs to be the next one. Okay, so now you run the tests, and magically all of the tests work. And now I'm done. Okay, well, now we've got something that keeps track of people on the list. You could now write a loop if you wanted to go through all of the items that are actually there and see whether or not they're there. We haven't bothered with a loop because we're writing unit tests at this point. Okay, so no loops typically in unit tests. Okay, Suppose that somebody dies.
So we need to remove
We need to remove them.
And bump everybody up who's below them.
So here's remove. What kind of information are you going to provide for remove?
Position.
Yeah, position is the only thing we know now. Eventually, we'll get a little sneakier and we'll start to search for people to remove, but for now, position is the only thing we know about them. You know, you get their union member number and you go, okay, they've got to somehow disappear. Okay, so there's remove, does nothing, so we should go right away and write some unit tests. So, going to write some unit tests. What's a good test to write first?
adding someone to the list,
Adding someone to the list and then,
checking list size and getting the position, and then removing them.
okay.
Can you just use one of those methods?
You could, but I'm going to make this a little fancier. Okay, if you were going to make a test for remove, would you write the simplest case or a more complicated case?
Both.
Well, which one would you start writing here at this point? Yeah, I mean, one of the things we talked about is in 132 is write the simplest case first. I'm going to suggest to you that, like I did yesterday, in this case, that when you're writing things with lists, sometimes the easiest case to think about when you're starting to write it is a case with a bunch of things in it where you remove one from the middle, because then you have a really obvious idea of what's going to happen. Okay? And so I'm going to actually reverse the process, and I'm going to say, let's write a reasonably large test case, just so that we have an idea of what the test case looks like, and then we'll go back and we'll maybe modify that to do some simpler cases. Okay, so I'm actually going to reverse the process. Sometimes you get caught. You have to be careful about that in testing, to not, to test things maybe in the order of smallest idea to largest. But when you're starting out with a new set of unit tests, it's actually easier to write a bunch of them. So let's just go, and what I'm going to do here is I'm going to make a union with 5 people on it. And for the 5 one, I'm just going to do union 5 dot add a B, C, D, oops. So I'm just going to, I know I'm going to do a bunch of things with a union that's got 5, and this is going to be removed from the middle. Okay, so I've just got A, B, C, D, E for tests. So if I do union 5 dot remove the middle one, which is 0, 1, 2, then what would you expect to be true?
D will be in position 2.
Before you even get to positions, size should now be 4. So if the size isn't correct, who cares about people in positions? There's something immediately wrong. So I think that the size should be 4 instead of 5. Now, it wouldn't hurt here if you want to make the unit test a little more clear, since some of it's up top, is even to just say that to remind people what it is. And so if I remove the number 2 position, what should I end up with?
You're also using union, not union 5.
Oh, sorry, yeah, better be careful about that. There's another problem, by the way, with declaring too much stuff in the setup method. You see, I only put 2 things in, and what immediately happened, I got confused about which one I was using. Okay, so the setup method has those advantages, but if you start putting too much stuff up there, oops, it becomes a problem. Okay, so there's something to be said for just repeating it elsewhere. But now I'm going to steal this code, and again, now have to be careful about union 5. And now I'll steal those. And that's now 2 and 3 positions should be A, B, skip C, so it should now be D and E. Okay? So there's one test. Well, okay, that's the easy test, right? Remove something from the middle. So now what are going to be the corner cases that are going to drive you crazy?
There's nobody in the list and you tried to.
Well, even before, just with 5 people on the list, what are going to be the ones that are going to be maybe the difficult ones? First and last. Okay? So it's a good idea at this point to say, well, if I removed one from the middle, I'm going to also try to remove one from the first, because if you skip the 0 position and accidentally do the 1, that's the one you'll get caught, or if you try to do the one before the 0 position, you'll get caught. So that's the trickiest of the lot. So if we remove now, in this case, the 0 position, we should have size of 4, and this is going to be B, C, D, and E.
You used remove 1, not remove 0.
And so change that to remove 0, thanks. And then we'll go down and we'll write the other case down here in order. So the remove from the end should be size is 5, remove the number 4 entry, which is the last one, size should be 4, and we should have A, B, C, and D. Okay? So there's a couple of quick unit tests. My advice here would be to write the, add the 0 case, just 1, and then try to remove it. Do those if you want. But now that we've got sort of something going, it's time to write remove. Okay? So get your pen and paper or thinking caps on, and I want you to try and write remove in the next 5 minutes. And I'll write some of the other silly cases for the removing the smallest ones. Just to help you out, I shown you a working version. I added some more unit tests. It passes all the unit tests. It works. Everybody got a version written? Okay, let's talk about this one. Somebody comes along and says, oh, you need to take over this list code that Joe Programmer wrote for us, and he wrote it yesterday, and now he's gone. Okay. Without looking at the unit test, does it work or not work? If you just looked at this piece of code and you didn't have any unit tests, and somebody said to you, I'll bet you $100 that code works. I know, but hey, you don't need unit tests. You're a heavy-duty programmer. You should be able to just look at that, and it's only 3 lines of code. How could it possibly be anything crazy? $100 works or don't work, so the unit tests. Don't really have a clue. Okay? What's weird about it?
Semicolon in the front of that page.
Well, it also
Okay.
has -2.
So, first thing that's weird is that there's a semicolon here when that's not the standard way that we're used to of writing a loop. Okay? And in 132, we only ever wrote a loop one way, really, from 0 to less than by 1, and now all of a sudden you go, oh, wow, that's different. Okay? Anything else?
The -2. It assumes
What the hell? You know, -1 I've seen before in code. That's not necessarily unusual, but -2 just sort of makes me feel a little weird, particularly when we're only removing one thing, and now all of a sudden I see a -2. What else makes you feel a little dirty? Less than or equal. It's like, anything else?
It's increment in P, and it's also adding 1 to it.
it's also decrementing next free fill.
What about that makes you shake a little bit?
It's because we're supposed to be getting the position, not adding 1 to the position, like.
If we're removing one, what do you expect to happen to all the ones that are beyond the one that we're removing? They drop down, meaning a smaller number, and what I see here is a bigger number. Okay, so I'm desperately expecting to see the whole point of the problem is that everybody afterwards, if you move 2, position 3 should move down to 2. So I want to see a -1 someplace, because that's the whole point of how you know the problem works, and there's nothing in there that does that.
Not to mention the fact that you're testing for a criteria where P will be smaller, but if P is getting bigger,
So but it works. Okay? So, if you've been given this code, and there's no unit tests, you've now stared at it for 10 minutes going, really? It's 3 lines of code and I'm just sitting here, I've spent 10 or 15 minutes. Company's paying me to do this. What are you gonna do with this code? You're immediately gonna chuck it away and go, I don't know what it does. I don't want to go anywhere near this stuff. Let me just rewrite it. So now your company just paid somebody yesterday a bunch of money to write this thing and scratch their head and do this awful job. And now you're coming along the next day, and rather than moving on in the world, your immediate reaction is, I'm just going to throw this away because I can't understand it, and I'm going to rewrite it into something that's decent.
That's roughly why that guy was fired.
Okay. That's my point about writing code like this, is that it costs you time, it costs the next person time, it costs the next person time after that, gets rewritten a whole bunch of times, people scratch their heads and go, well, I don't know if this works or not. If there's no unit tests, it's even worse, because it's like your initial reaction is to say, oh, that -2 doesn't belong there, let me fix that. Let me change that to a -1 because it's got to be a -1. Or, oh, look at that +1 there, that can't possibly be right. He must have meant a -1, just let me go change that. Well, if you change anything that's in there, you'll break it. If you don't have the unit tests, you'll send out code that doesn't work. Because that one actually works. Okay? So, now let's fix it. Okay. Oh, by the way, that P isn't helping. And in my original code, I actually changed that thing to AND, just to even make it even more confusing so you couldn't tell whether AND was the one before or the one where you actually wanted to put something. Okay. So let's just ignore that one for a second, and let's do a visual. We've got this array. We've got some number of items in there. There's 5 items. If I say, there's the one I want to get rid of. Okay? Now it's time to draw a nice diagram. What do you want to call that then?
One to remove.
Okay, so one of the problems with that thing is, even if it says position like it did in the original version, position doesn't really give you a sense of what it is, where that thing does. Okay, suppose that we remove that one. What's the interesting one? What's the next interesting question?
One after that.
If there were a bunch of them down here. Good question. So how many are there going to be? From this one minus that one is about the number to remove, give or take 1, close enough. So what's that one? Size or
Yeah.
next free slot?
-1.
Maybe -1, who knows, we'll figure it out. Minus,
1 to remove.
well, or one after. So the one after is the first one to move, and the other one's the last one to move, so it's more or less the difference between the two of them. But close. Okay? So, one last thing. What should happen with that one?
It should move up
It should move
to the position previously.
previous position, which is -1 from where it is now. Okay? So the whole important thing when you're looking at this thing, your reaction is, I want to make this thing move down 1 to start the process. Okay? So let's just go back and rewrite and change this to, what do we call it? 1 to remove. And let's just get rid of all of that garbage in there for the moment. Okay? So we had, we've got 1 to remove. 1 after is what?
1 to remove plus 1.
How many is
Next free slot minus 1 after.
next 3 to fill, sure. What's the thing you want to do if you wanted to do one of them? Just one.
You set 1 to remove to 1 after.
Now, if I just want to slide this one, and this is all workers,
All workers.
Yeah, all workers
one,
position.
1 to remove equals all workers.
so the one from all workers, we'll even do it, we'll write this one a little backwards. All workers from where it is now, which is, we'll call it I for want of something better, needs to move into all workers sub I minus 1. Okay? So now let's write, we have to do that more than once. Standard loop is I equals 0. I is less than how many? Do that. Tab that one in. Anything we've forgotten? Just make sure to run the unit test. Index out of bounds. First guess is,
We didn't declare I.
no, I's there. What was your guess about how many? Maybe minus 1. Let's just look at this one. It fails there. Remove first. Oh, that looks like a good one. So remove the 0, 1, and it's getting an index out of bounds because it's 1 off of where it should be when it tries to remove the 0, 1. So the position is wrong. It's 1 less than it should be. So let's go back in here and let's say it needs to start at, we're always starting I at 0. Sorry, this isn't all workers.
Yeah.
Sub I, we need one more variable. What's the one we're interested in moving? To start with.
One after.
So actually, we could have used one after in there, but that's okay. So this is actually the one to move. Goes from wherever it is. Sort of like that. I think I can maybe get rid of that thing just for fun. Maybe not. Put it back in. How are we doing? Remove middle. Last one's wrong. Remove first. The second one is wrong. So this is go through however many we have to do. Okay, now we'll work backwards. Is that line right? Gotta be, because it just goes from where it is to -1 of where it is, which is what we know about the problem. Is that line right? This line has got to be right, because you're just moving however many you have to move, no choice.
But you need to change the start position.
But so 1 to move,
But actually, the old workers, the one to move -1, shouldn't be that on the right side?
Oh,
Shouldn't be
sorry.
the right side?
so 1 to move needs to
Add one to it.
go up so that we move the next one. Got it. And I think I've just got, now I can get rid of my silly -1 there, since we've played with it so many times. There you go. A little bit of cleaning up to do. Now, if we work backwards, if you're looking at this code for the first time, what's the first thing, what's the important part of the problem? The first thing that you're going to do is you're going to go and say, are people moving backwards in the array? So that makes me feel comfortable. If I move one backwards, then the next one that I'm going to have to move is the one immediately afterwards, going up. So it makes sense that the next time I go through the loop, I'm going to have to go to the next one higher and shove it backwards. I'm going to have to move however many I have to move. Where do I start? I start moving with the one after. How many do I have to do? Well, that's just the difference between the ones from where I was, the extra ones. Which one of those two pieces of code would you rather work with? The first one that I gave you? Or this one? Okay. Notice the difference in style. One of the reasons I pointed out to you is that the first style you saw was 1970s C programmer. That's what the code looks like, because the emphasis was on making sure that the compiler could do its job and use the minimum number of variables, use the smallest number of registers. It was all about making things more efficient for the computer, and it didn't matter how many people had to stare at it. And most of the people who stared at it had math backgrounds, and that sort of thing would be more fun for them. Okay? In the modern world, it's not about the computer anymore, it's about who gets to see your code next. And so anything that you can do to improve the look of the thing also helps. And the other thing that's going to help in this class is drawing the diagrams and labeling things on the diagrams with good names, because as soon as you get the labeling done, it makes your life easier in terms of figuring out what's going to happen. And if you try to play the thought experiment in your head and try to visualize the diagram, it's almost never going to work for you. Okay? So this is a lesson not only in modern coding, but in saying we need to do this for the rest of the class. So you'll see me drawing a lot of diagrams to try to show you what the important things are. Okay? And I'll put that other little piece back in there so that you can get both versions. I'll break my rule about commented out code. Done for the day.